Hello guys! Welcome to a new video of the complete course of Java for Beginners. In this video I will show what's the inheritance, the polymorphisms and the encapsulation. For that I will show the abstract classes and the interfaces and the usage of this and super. Take your keyboard, a cup of coffee and remember to subscribe to my channel and let's go! You can find the project I'm using in this video in a link in the description. You can download and repeat the same operations as I do and train with the final tests. Let's start with the interfaces, which will answer the polymorphism pattern. The interfaces are some kind of classes in Java. They are classes which have no behavior, which are empty. The interfaces are only a guide to another class. Let's create an interface. Some people use the I at the beginning to indicate in the name that's an interface. But nowadays, with the performant IDE, you already have the icons which shows you it's an interface. Okay, the operation interface does nothing by itself. It's just a definition of a mathematical operation. The interface will guide me to what a real operation must do. A real operation must have the following methods. As you see, there is no method. I don't use the curly brackets, directly the semicolon. The interface only defines the method signatures. Accept the first argument, accept the second argument, and calculate the result. Now I will create a real operation. I will create the sum. I specify that the sum must implement the operation interface. Now I have errors. I have to define the methods and add the behavior. I will create another class which also implements the operation interface. Now I have two classes which implement the operation interface. Now I can show what is the polymorphism. How do I instantiate an object? This way. Or with the var keyword. But I prefer not using it now. But as a sum or a subtraction is an operation, on the left side I can specify operation. I can't specify operation on the right side because operation is an interface. It has no behavior. Now, the polymorphism means the following. Calculate result will return a different result will have a different behavior depending on the class used. The same method from the same interface will act differently depending on the implementation used. This way I have the sum, and if I change the constructor without changing any methods, I will have another behavior. I don't have to care about the class used to call calculate result. It will act correctly depending on the instantiated class. Let's go now with the inheritance and encapsulation. For that, I will use an abstract class. I will modify the operation interface to be an abstract class. The abstract class is very similar to an interface. Neither can be used alone. Both guide me to the final behavior. The interfaces need an implementation to define the complete list of methods. The abstract classes already have implemented methods and only need classes to extend their behavior. In the case of the operation, I have the same behavior to start the first and the second argument. It won't change if it's a sum, a subtraction, or multiplication. I always have to read the values and store them in internal variables. This behavior is encapsulated in the abstract classes, and I store the arguments in the abstract class. The abstract class has a state. It can have internal fields, and those fields can be accessed from the classes which extend it. How? This time I must extend the abstract class. And I can remove the method which is already implemented in the abstract class. Until now, I've used the this keyword to access the fields from the class itself. This means this object. How to access the fields from the abstract class. How to access the fields from the parent class with the super keyword. The super keyword allows me to access the fields and methods from the parent class. And from the usage, the abstract classes act exactly as the interfaces. You can have them in the left part, but not in the right part. Both the abstract classes and the interfaces act like a facade. You don't have to care about what's behind. Just call the methods and the correct implementation will be used. I use the interfaces when I have different behaviors for similar operations, like the mathematical operations, and I use the abstract classes when some behavior is common. Nevertheless, if I don't have a lot of common behavior, I can still use the interface with the default method. Instead of declaring the signature of the method in the interface, I define the default method. I define the default behavior. The rest acts as an interface. And the inheritance, I can have an interface which extends another interface, which extends another interface, and so on. The same for the abstract classes and the regular classes. You can extend them as many times as you want. This is inheritance. Those are powerful tools, but it can be complicated to use. Here, you have some exercises to train a little bit, both in the inheritance, polymorphism, and encapsulation packages. Read the comments, write what's asked, and run the test as follows. Right-click, Run As, JUnit Test. Correct the test until this bar is green. When done, you can check the answers in another link in the video's description. Watch the video again, make sure you understand those concepts because they are very important and powerful. Click on the like button, subscribe to my channel, and see you in the next video. Bye!